In today's video, we're going to talk about how to protect your AWS account or any other cloud provider's account from unauthorized access. Let's go. Now, with an AWS account or any other cloud provider account, you have a lot of possibilities. You can use an almost limitless pool of resources and spin up instances and databases and use managed services. But at the same time, you carry a lot of responsibility because it's in your responsibility to protect the account from unauthorized access. And you don't want people who are not part of your team or your organization or your company to use all of those resources, because essentially you're paying for them at the very end, right? So it's important to devise and come up with a strategy very early on to protect your AWS accounts and to put measures in place where even if an account was compromised, you are able to detect it very quickly. And in this video, I brought 3 chapters with a few high-level thoughts, but also very hands-on practical things you can do. And you can get started today. Now, before we implement anything, let's think about who is wearing the cloud security hat. Is there somebody who feels responsible for cloud security, right? Somebody who may take decisions about permission management, about auditing, and somebody who is maybe day-to-day auditing and reviewing all of the things that are going on in your cloud accounts, right? So it's critical to have somebody who has this on their mind and who feels responsible for security in the cloud. This doesn't have to be a full-time role, right? So this doesn't have to be, if you're a small team, you won't have somebody who is only taking care about security. But make sure that there is somebody who wears this cloud security hat on a regular basis and who drives forward security and security best practices in your infrastructure and in your cloud infrastructure as well, right? Maybe at some point it's very important to educate team members about social engineering. And if there is somebody who has this on their mind at all times, you as an organization, as a company, as a team will benefit greatly from it. At some point, when you've built things in the cloud, and maybe they're not productive yet, or maybe you're just experimenting, but at some point you will have to come up with an identity and access management strategy, right? So in the beginning, it's maybe just you or a handful of people who access cloud resources and they deploy code or they make changes to something. But later on, when you go into a live state and you launch something to the public, you need to come up with this IAM strategy to make sure that the right people in your teams and the right people in your organizations have access to whatever they need. And so there is a distinction we make between giving people, so humans, access to those resources and giving machines access to the same types of resources. And we'll talk about both. Okay, let's talk about people first. Think about all the people in your organization that need access to your AWS account and try to maybe put them into certain groups or try to organize their level of permission into groups. And this is where IAM groups come into play. So essentially, it's a group of users that will have the same level of access. So maybe you have 2 different development teams and you have one team that does mostly operations. So you could come up with 2 different groups for development team 1, development team 2, and a 3rd group, which is the operations team. And then you start writing your IAM policies. Let's say development team 1 is building a web service and development team 2 is building a front end for that web service. So you would give, in those IAM policies, you would give access to those resources that the development team 1 builds, and you attach that policy to group 1, and you design a different set of policies and then allow and deny type of statements. You write into a second policy, attach it to the second group, and the same for your operations team. And this way you can structure your permission management for actual humans, for people, into IAM groups. And you can already see that here, because we're dealing with people, we have to be a bit more flexible, right? Because if you're too strict, and we talk about the least privilege principle in AWS, where you try to give entities only the permissions they really need. But with people, you can already see that you have to strike a balance between being too strict and being too open, too lenient. If you're too strict with permissions of, let's say, your developers or your ops, it creates issues. It creates, first of all, lag, because if somebody doesn't have the permission that he or she needs, then it's the typical, oh, I have to wait until somebody approves my permission request, or I have to wait until this and that happens. And it creates frustration because nobody wants to wait, essentially. And second, it hinders innovation. It hinders people from trying new things, maybe trying new features, trying new services, this type of stuff. And you want people to experiment and then maybe build something, even if it's not immediately in their day-to-day job, but you want them to have the possibility to build new stuff and come up with useful things for the organization or for the company later on. So to counterbalance being a bit less strict with permissions for people, you should definitely implement multi-factor authentication, so MFA, right? And this is very easy with an AWS account. You can enforce the usage of MFA for every sign-in, for every user. And I'll leave a link in the description below, so that people have to use MFA when they log in. So they have to have another factor of authentication, let's say a mobile phone app like the Google Authenticator. And only if they use that second factor for logging in, they can use the resources in the account. Very important. This does not mean that you should give full administrator access to all of your developers, all of your employees. So in a second step, you think about programmatic access. So giving machines, EC2 instances, whatever it is, could be on-premise, could be in a different cloud. How do you give access to those types of resources and entities, access to your AWS resources, right? So let's say you have a Kubernetes cluster running somewhere, could be in an external cloud, and you want to give it access to your Amazon SES, your email sending service. There, you really want to employ the least privilege principle, because this is a machine, right? Machines won't get frustrated. You want to lock it down as much as possible, so that the credentials that you place in this Kubernetes cluster can only use the API or the APIs that are absolutely necessary, and nothing else, right? So that's your first barrier, so to say, that even if those credentials get lost somehow, the attackers can only use that single API. And then you may want to put a second line of defense in place. For example, you could limit in an IAM policy the IP range to only the IP range of that Kubernetes cluster, so that every request that does not originate in that IP range cannot use that API of SES. So another very simple example of the least privilege principle would be, let's say you have an S3 bucket and your iOS application that you developed needs to access that S3 bucket. In that case, the iOS app would only need read access, maybe, and only to a single bucket. So instead of giving it full S3 permissions in your account, you would clearly define in your IAM policy that the app can only access this one bucket and can only read from that bucket. You can think of many different ways, and not every approach will work in every use case, but try to put multiple lines of defense in the way of potential attackers. Very important, don't ever take those credentials and commit them into a code repository. Because code repositories, whatever things go wrong, people have access that shouldn't have access, and you don't want clear text credentials in your repositories. So there are mechanisms for these type of things. And if this is, for example, a software as a service provider and you need to provide credentials from your AWS account to them, they will have some sort of mechanism. They will hopefully encrypt those credentials and so on. What you should also consider using is either the AWS Secrets Manager, which is an API that you can call to retrieve temporary credentials, or if this is about deploying or giving temporary credentials, temporary access to users of your website on a front end, then you may want to use something like Cognito, which has the same type of principle. It's using the OpenID Connect standard, for example, and it will also just give temporary access credentials to your website users. Okay, the last topic for today, cost control. So you may not think of cost control as like a security measure per se, but if you think about defense in depth, so putting up multiple layers of security, then keeping control over cost and very tight control can be another measure of security. And it all starts by gaining good visibility into the spending of your accounts, of your cloud spending. So in AWS, you can do that, for example, by using the Cost Explorer, which is a tool that gives you full visibility in all the spending that happens in the account. So you may want to go a step further by using tags. And that means you have your AWS account, and let's say you have two teams working on two different projects. One is a website and one is some sort of a backend service. Then you use two different tags, for example, and you put one tag on all of the resources of the website, maybe S3 buckets, maybe a CloudFront distribution, and you put a different tag on this backend service, on the backend service resources, maybe EC2 instance, maybe an Elastic Beanstalk environment. And now you have clear visibility, even if there's overlap. So let's say maybe both of those teams use S3 buckets. In your Cost Explorer, because you're using different tags, you see clearly these S3 buckets, this type of stuff, that all belongs to this team and this service. And this other bunch of things belongs to that other team, to the other project or different service. So you get full visibility, and you also get historical trends, right? Because by using this tag, you can look back in time and you can see, usually this service is X dollars per month, and usually this service is Y dollars per month. And now, because you have this visibility with more structure, you can use budgets and alarms to see if the spending changes dramatically in 1 month. And this is usually a sign, and think of it as an anomaly detection. This is usually a sign that either you're growing very fast, which is great, or maybe somebody took over, compromised some credentials, and is suddenly spinning up instances to do Bitcoin mining or something like this. So there you can, as I mentioned, you can use those budgets and those budget alarms to say, let's say on the overall spending, or on the spending of one type of service, I want to be alarmed if the forecasted spending crosses a certain threshold, right? So let's say usually you pay $300 per month, and if the forecasted spending would cross 400, and you want to get alarmed, and you can get alarmed via SMS notifications or via email or via text messages. And even if this is not real time, not too bad, maybe you have other security measures, but if that person or that malicious actor was able to kind of sneak through all of that other stuff, you would see that the spending is growing in one area or in one type of service, and you could at that point intervene and cut off access, delete credentials, or spin down those instances. So see it as another level of security because you get more visibility into what's going on in that account. All right, that's it for today. We discussed 3 topics in the realm of protecting your account. We discussed the cloud security hat. We discussed your IAM, your identity and access management strategy. And we also talked about cost control and how you can use budgets and alarms to control not only your cost, but also potentially detect things that are going on in your account. Let me know what you think. Let me know if you're doing things differently, and I'll talk to you soon.